Well, last month, 4 mini-substations in Joburg blew up when Eskom restored power after scheduled load shedding. That led to several areas being without electricity even after load shedding ended. You'll know how often this happens. Look at what happened in El Dorado Park, where a substation caught fire, I think twice in the end. Well, to talk more about the impact of load shedding on substations, Nicolaas Esterhuysen is the Director of the Engineering Services at the University of the Free State. Nicolaas, good afternoon to you, and thank you very much indeed for your time. We're now going to see substations going on and going off again. They're going to be basically switched off and switched on. What happens to a substation when you do that?
Well, Stephen, the fact that the technical term that we call this is called cold load pickup. And this is a phenomenon which we get during a time when there's extended period without any power, and then when the power comes on, all loads in that vicinity switches on immediately and simultaneously. So in this case, it would be, for example, geysers or air conditioning that would occur, that the temperature has now dropped, and in order to compensate for that period that these devices have been switched off, they switch on simultaneously. And this causes excessive loading for a short period within that mini-sub or transformer within the substation. So during a course of load shedding, where this happens multiple times, the combined effect of this intense load on the substation causes failure of that substation.
Does it actually lead to some of the substations catching fire? Is that why we see this happen so often?
That can happen. There's various different things that can go wrong within a substation. The transformers is one part of that, but if the switchgear is stretched beyond its limit, if the cable terminations and the cables themselves are stretched for that period of time above their design capacity, then that can be a cause for fire.
Is the major culprit here geysers? I mean, so many people say a geyser uses 40% or more of your electricity, and they all switch back on at the same time. A computer or a television uses hardly anything. A computer doesn't use very much. But a geyser uses a lot, and they all switch on. They're all switched on at the same time when the power comes back.
Yes, you're 100% correct. The geyser does use the most electricity within a household, and that's the same for air conditioning load, which consumes a lot of power. So we're going into winter times now. It can be the same for heaters as well. So during this time, everything switches on simultaneously, and that causes the excessive load on the substation. As you also indicated, the lights and computers and these things doesn't have that much of effect. But for an entire city or an entire piece of city, it can also accumulate to a huge load.
So, I mean, people will sometimes say, and certainly, my local WhatsApp group will say, during load shedding, if you've got a problem with the substation, everyone please switch off your geysers. Go to your DB board, find it, open the door, flick up the switch to switch off your geyser. If everybody does that, if you do it in a coordinated way, would that make a difference?
Yes, that would make a huge impact, and that is one of the areas that we as normal citizens can contribute to less the burden of load shedding upon our infrastructure. That is one of the ways in order to do that. Unfortunately, depending on where load shedding occurs, it's difficult to always do that in a coordinated manner. But that would be one of the best ways normal consumers can assist with lessening the burden of load shedding on our equipment.
The other issue is that then if substations, if we know this is going to happen, so if you're running the city of Joburg or if you're running Mangaung, for example, and you know there's now going to be load shedding for a week, is there any way you can prepare a substation? Can you do a lot more maintenance in advance?
It's a difficult question because load shedding is usually, like we see now, announced for a very short time period. Normally the municipalities and electricity distributors do have their preventive maintenance schemes. So the advice that I would give there is that we must increase that preventive maintenance schemes, there's various methods we can maybe see how to pick up these failures preemptively instead of waiting it to occur on the load shedding conditions. But it is a mammoth task ahead of us.
I suppose what you could do as well is you can coordinate better efforts, you can put more maintenance into substations, but it would just be easier to stop load shedding. I mean, that would stop this problem from happening. More and more people are also getting backup electricity. Businesses are doing it, shopping malls are doing it. Does that make any difference to the load that substations deal with?
It will depend on how your personal backup system at your house is normally connected. Most of the people, and we also advise people not to put their heaters on emergency power, just because the capital expenditure in order to accommodate that will just be so much more. So most of the households do not have heavy loads such as heaters, stoves, and air conditioning loads on their backup reserves. Only loads that is required emergency power loads, such as lights, sockets, computers, TVs, and these things are on there.
Is there anything else people can do to reduce the load? I suppose all they can try and do is, try and help their cities, their municipalities, to manage their substations during this time.
Yes, I think people sometimes underestimate the small part that everyone can do. And if there's a big collective effort from each and every South African to use energy, sparingly during this time, and even then, when we do switch back from load shedding, if everybody do their part, it can make a huge difference.
We're going to see this problem more and more. I presume the older the substation, the worse the problem. So you could see in some areas, older areas, sometimes older areas are richer areas, but you may find that actually the older the substation, the more damage it does, the more problems it creates.
Yes, that is also true. Normally we plan for medium voltage networks, we plan for a lifespan between 30 and 40 years. So these are equipment and a big capital investment in order to upgrade such infrastructure. But with the compounding effect of regular load shedding, it's difficult to achieve, I will foresee it's difficult to achieve those numbers again. So all electricity distributors need to ensure that deep maintenance is being done on substations, on switchgear, to prevent these things from happening.
Nicolaas Esterhuysen, thank you, Director of the Department of Engineering at the University of the Free State. The break